Hello friends, today in this video we will see regarding the unit number 5 of our subject triple M, force, torque, pressure, strain and temperature measurement. This unit consists of 14 marks as you can see. So today we will see the how to measure the force and how to measure the torque. In this video we will see only regarding the force. Now force measurement. Normally the force can be defined as a cause that produces resistance or obstruction to any moving body, or the change in motion of a body or tends to produce this effect. Force is usually applied to calibrate device which resists the force and indicate or records its magnitude. We know the definition of force. Force is an external agent which is acting on the body, and because of that any body which is in rest remains in comes into the motion, or any object it is deflected from its original shape, depends on the intensity of the force. Now the unknown force may be measured by the following methods. There are different methods how to measure the unknown force, because when we are measuring the parameters, the known force is already known to us, but if we are measuring the unknown force, how to measure it? So the first method is the balancing. Friends, you have seen whenever you go to market, or you have seen a weight balancer when you are purchasing something from that. On other side the weight are kept, on one side the material or mass which you are purchasing, that is kept. So this is one of the method, that by balancing two different by balancing the two different pan, we come to know the mass of unknown, or we come to know the force of unknown force which we need to find it out. The second method is an elastic spring or elastic member, with the help of whom we can find out the force. Spring, beam, cantilever or probe ring, that we will see later in this video. The other method is translating the force to a fluid or pressure, and then we can measure it. Hydraulic and pneumatic load cell work on this principle. The next other method is applying force to a known mass and then measuring the resulting acceleration, also give us the measurement of the force. Balancing force against a magnetic force, which is also developed by the interaction of the magnetic or current coil. So friends, here you can see there are different 5-6 points to measure the force. Now in this image you can see, friends, how the balancing mass is being used to find out the force. By suppose this is the standard mass, this is known to us, and this is the unknown mass, which is whose force we need to find it out. So by balancing this, we can find out what is the weight, and from the weight we can find out the force which is used to measure the force. So friends, you can see how we need to find it out, the force from this. Here W1 is equal to W2, weight on both the side are balanced, and from that we can find out the force or the weight of a mass. The second method, it is unequal arm by balancing of the unequal arm. You can see here in this diagram, this mass or this arm is shorter in length and this arm is longer in length. So how we need to find out the force by balancing this arm? So one of the formula is there, here you can use. This is the W2 unknown mass and this is the W1 known mass. So by balancing the moment on both the side, for example W2 into A, this is the pivot point. So the moment which is generated on this side can be measured, or the moment on this side should be equal to the moment on this side. So by this method you can balance out, you can equate the moment on both the side, moment on this and this side, and find out the W2 which is unknown mass, which we need to find out. So W2 is equal to W1 into B by A. All these values are known, only W2 is unknown. So from that we can find out the unknown force. One more other method to find out the force is a multi-level platform scale, which you are seeing in this figure. You can see this is the platform. W1, W2 are the two weight which are acting at the point, and W is weight which is acting on this. This is the fixed point, again this is the fixed point, and whatever the deflection is generated on this lever will be calibrated here. Here, when the weight is balanced in this, the mass which is placed over here, you have to arrange this device in such a way that it balances between these 2 points. So when this pointer remains at the center, we will come to know whatever the mass is placed over here, the value of that mass will be identified here. You have to move this lever or this weight, poise weight, which is termed as poise weight, on the right hand side in order to balance it and bring this pointer between these two nodes. When they are at the center, when they are balanced, the value which we are generating, we are getting here. Actually this is the weight which is calibrated on this scale, and that weight we can note down and we can mention it. Friends, this is one more pendulum scale which does not measure the load, but it measures the torque. Whatever the weight you keep here, and this is the roller or pendulum which rotate on this screen. Now how you place the weight on this and balance it, this is the weight scale or calibrated scale which will reflect the value of this mass which is placed on the on this table. Friends, I told you in the beginning that there are different methods to find out the force. Here you can see this is the elastic force meter, where the spring elastic element like a spring, rod or cantilever or simply supported beam or ring or bellows or diaphragm are used in order to measure the force. Here you can see directly a scale is calibrated on this. Normally we this is a domestic appliance which we take into the consideration, that is spring loaded balancer, with the help of which we can measure the weight. On the scale the weight or kg is mentioned. Load the load, whichever you need to measure it on this hook, lift it, let this load be hang in the air, and whatever the deflection you will find or the load which is mentioned here, you will be easily find out the load. Here this is the formula, F is equal to kx, where k is the stiffness of the spring and x is the deflection. So based on the deflection you can find out the force. Friends, this is a cantilever beam load cell. This is the cantilever beam. So you can see in this figure that whatever the force is applied based on the deflection, the load cell is kept here. Based on this deflection, the load cell will generate some value, and that value will be termed as the force which is applied on the beam. The diagram which you are seeing in the screen, it is a probing ring. If you see the construction of this probing ring, it is having an external boss. Here you can see this is the internal boss, this is the reed, this is a steel ring. Now here a dial gauge is placed, the screw and nut is placed. You can see here initially the 0 is set, and the work or force which we need to measure is applied at this point. When the force will be applied, this spring will try to compress, this ring will try to compress, and this compression will deflect this dial gauge, and based on this deflection or number of rotation, whatever the deflection of this ring has been measured, the reading will be taken of this in order to calculate the force. In this figure, this is a hydraulic force meter, where the hydraulic principle comes into action to measure the force. Now you can see the construction here. This is the diaphragm, and above the diaphragm a loading platform is given. Below the diagram a oil is filled, and this oil is connected to a pressure gauge or burden tube type pressure gauge. Whatever the load is acting on this, because of this load, when a load is applied on this platform, this loading platform will try to move downward. Whatever the fluid is kept in this, that fluid will generate a pressure on this dial gauge, and this dial gauge will give you some value. That value, it depends on the dial gauge. If it is directly calibrated, that value will be measured, and based on that we can easily find out the force. Here, friends, you can see a pneumatic force meter load cell. As I told you in earlier stage of this video, that there are different methods to find out the force. This is the pneumatic force meter. Now you can see here a load cell is given, loading platform is there, a diaphragm is placed, here a needle is there, a bleed needle. Now the air is being supplied here. What happens in the initial stage when no load is applied? Whatever the air is entering to the chamber will be moved out from this bleeding valve. Now when the load is applied on this, what will happen? Slowly this bleeding needle will come down and set in this, and this will reduce the area initially, and as the area is reduced, whatever the air is entering will create a pressure on this manometer on this side, and that deflection will be measured and will be calibrated or calculated to calculate the force. If excess load is applied, this will completely close this bleed valve, and whatever the air is supplied, that pressure will be created on this manometer, and this manometer will show the deflection. That deflections will be measured, and based on that the force will be calculated. Okay friends, so these are some of the techniques to measure the force. Thank you.